Hello, this video lecture will be focused on missing data, what to consider when we're looking at missing data in a data set, and some options that are available to the researcher when they want to try to account for that missing data and take care of it. So when we think about what missing data is, it's information that is not available for a subject or the object in which you are investigating, yet other information is available. And typically what we're concerned about here is when there are noticeable patterns of missing data where the missing data becomes predictable, or the missing data represents some predictable element of our subject. So that's what we want to be concerned about, and we sometimes think about this as being systematic or random. And if the missing data in your data set appears in a routine or patterned way, it may be systematic, and we want to deal with that. Perhaps. If it's completely random, then that's another issue that may not be correctable, and it might be something we are willing to accept as a researcher or deal with in some other way. So our concern then is to identify patterns and relationships that may exist or may be present when missing data is also present. Above all, though, we want to be very careful about how we deal with missing data. When we eliminate cases or variables, it means that we're eliminating our statistical power, but then it's also the case where we're reducing our sample size, and that may be troublesome. However, if we keep missing data or keep observations that have missing data in our data set, it may serve to undermine or distort the results that we're eventually going to get. So missing data is something to think about and a concern. It generally is not an enormous concern. In other words, it usually does not present a big enough problem to derail your research. But you want to be able to think about it as a limitation probably of your research if it exists. So there's a step-by-step process that may be used or at least considered when you're thinking about handling missing data. You want to think about how the missing data appears and what type of missing data it may be, how severe the missing data is, or how much, to what degree it exists, in other words. And then we want to be able to think about how we'll deal with the data that's missing, whether we will try to correct for it or whether we will just let it go, whether we'll try to eliminate cases and things of that nature. Okay, so that's generally what we'll do when we think about this process for dealing with our missing data. It may be that we want to replace our missing data with some other values, or we want to completely eliminate cases. But again, we want to be careful when we think about doing that, because we're going to be dealing with sample size issues if we in fact are up against that. When we start thinking about the type of missing data that we have, some missing data happens just as a result of collecting data. Sometimes we might call this ignorable missing data. In other words, the data is missing, but it is missing for some specific reason that we would expect. And so the fact that it's missing is not necessarily a concern, because it's explained in some research, in some element of the research or the process that we're doing. So missing data could exist because some respondents simply don't respond. So non-responsive members of our sample, they're missing, and we don't have data for them, but they're missing because they chose not to take the survey, or they were not asked to take the survey, or something along those lines. So given that we're doing a sampling and not a census, it means that not everybody in the population of interest will be asked to take the survey or have the survey available to them. So therefore, they're missing. So this is something that we would expect as part of the research process. Other data that's missing might be as a result of some type of skipping or movement in the survey that is logic driven. So for instance, if a respondent is asked if they bought a product, and then for those who bought the product, those respondents get a series of questions, but for those customers who did not buy the product, they might be skipped to another part of the survey, and therefore they will have missing data for those questions that refer to the purchase that they were asked about being made. So in other words, the respondent was skipped throughout the survey, and they of course will have missing data because they were never asked questions that others were asked. Other situations are censored data. So censoring data is when you have upper or lower limits applied to your data set. So the example here is if you study alcohol consumption and you recognize that there are certain laws that prohibit underage drinking, then there may be a age limit like 18 or 21 that prohibits your sample from responding because they don't meet that age limit. There's a constraint there, and that would be, so there might be some oddities in your data where you have missing data from individuals who don't meet that age requirement. Okay, so those are ignorable like types of missing data, and we see this from time to time where data will not be there, and we'll scratch our head and we'll wonder, whoa, we should have data here, but in fact, there's a reason why we don't. Other types of missing data, though, is non-ignorable. So this is missing data that we are concerned about, and generally it happens when there are openings, there's empty space in our data set where we're looking and we think there should be data, and we can't explain why it's not there. So missing data that is in your data set that you can't like explain real easily or simply, that would be a cause for us to look further and try to understand why the data is missing. Other reasons, like if we have some significant mistakes made in the data collection process that caused data to not be there, so that would be a reason to be concerned. Other than simple sampling error problems, non-sampling error problems would cause us concern. And then also, and very importantly, if we see some pattern of missing data, then we would want to be concerned about that as well, and that would warrant additional investigation. So we want to think about why the data was missing to begin with, whether it was ignorable missing data or non-ignorable missing data. And then we want to, number two, look at the extent to which the data is missing. So what we can do is we can look by respondent, like each individual respondent, and we can think about like what percentage of the survey was completed by each respondent. So if somebody filled out the survey completely, then 100% of the survey would be completed. If they only filled out half the survey and the other half is blank, then 50% of the survey would have been completed. So that's one of the things we would look at, and we'd want to set a benchmark level. So like say if 80 or 90% of the survey was completed, then that may not be problematic. It may be something we would be willing to accept, given the idea that some respondents aren't going to fill out every single question, but they may only fill out, they may fail to fill out some of the survey or answer all the questions. Another way to look at it is the look at the number of respondents by variable. So if we look at one variable and we see that a lot of the respondents didn't answer that question, then it may be something that we want to be concerned about. So one of these questions might be gender. If we ask the respondents what their gender is, you can expect that maybe 20-30% of the people, upwards to 20 or 30% of the people may not respond to that question because they simply don't want to let you know this personal information. They don't want to respond and indicate what their gender is. And that doesn't necessarily mean that their response should be thrown out. It just simply means that that one question or variable is perhaps not adequate. So sometimes we'll set a benchmark and say 10% perhaps for individual cases might be something we would accept, but anything more than 10% might be something that we'd be concerned about. And that would be something that we would think about. The other issue we deal with sometimes is if we start eliminating respondents, that are more than 10% with missing data, then we may not have sufficient power to be able to do our multivariate analyses. So we got to keep in mind what we want to do with our data and how, if we start dropping respondents, how that might impact the overall effectiveness of the research method that it is concerning given the data that we're going to be using. So as we delete cases and variables, then we want to be cognizant and aware of if the data is non-random, that the missing data or the missing points would be due to some pattern. But also, so definitely think about taking them out if that's the case. If you have a sufficiently large sample, then you can get away with dropping respondents, yet keeping the power of your data set. So that we want to think about. And then also, sometimes we collect data using variables that are not part of the main part of the research that we're trying to study. So we may have a model, for instance, and gender may not be a particularly important piece of the model. And so in that case, even though we collected data on gender, it may be okay just to drop that variable or not use it in the analysis because it's not a key feature of the model that we're trying to specify. So if the variable is not a key component of your research project, then it may be okay to drop it and still have success in completing your project. Okay, so variables then, again, this is a benchmark figure with 15% of respondents not responding to that question may be considered for deletion. Again, as long as the variable doesn't disqualify your research objectives. So if the variable is not a specific component, like it can't be a dependent variable. If it's a dependent variable, you need to keep it, and then we need to address missing data in another way. The other thing is if we do a higher order construct, we should have multiple variables that would measure, like the latent construct or it's the subjective variable that we're measuring with multiple items. If that's the case, we can usually drop a few items and it's not going to be a problem. Okay, so those are examples then of when we feel okay to be able to do this. So another thing that we can do is we can do an analysis where we perform our model between the full set of cases and then the reduced set of cases once we delete subjects that may have missing data in them, and we can look and see how that change is going to impact our overall findings. So we can actually use that as a basis for deciding whether we drop some in our sample or not. We can look at what the impact of dropping them would have overall in our research findings. So moving forward then, what we want to do is think about, and again, I would go back to this a few times, the randomness of the missing data is really the important thing here. So there's two categories, if you will. There's something called completely at random, so missing data completely at random. So that would be the MCAR, missing data completely at random, and it means that there's absolutely no pattern in the missing data. The missing data variables can't be predicted in any way. That's good. That's kind of, I mean, if you're going to have missing data, that's the type of missing data that you want, because there's really, you really can't do anything with that, but it doesn't negatively impact the relationships between your variables, in a way that would be concerning. The missing at random, or the MAR, is a slightly more concerning case of missing data, where there are some indicators that the data that's missing is not randomly there. Okay, so this is a concern, and we want to try to deal with this in a couple different ways. In some cases, you can actually you can create a dummy variable that would indicate cases that have this type of missing data. And then we can account for that missing data. So in other words, we can create a new variable that actually captures the predictability of of the missing data. And then that predictability is used to build into your model. That's kind of a complicated way. It's like an instrumental variable type of an approach, or where we're using a second variable to account for the predictability of the missing data. So we don't do that a lot, but that's an option that could be used here. And then another way we could consider this is if there are other variables that behave very similarly to the one in which we have a lot of missing data, we could use those other variables as an indicator or a control mechanism, if you will. In these two cases, we want to control for the randomness, that's the predictable portion of the randomness. So here's an example where in a medical study, for a particular treatment, if the treatment causes discomfort, then you may have patients drop out because of the discomfort that's caused. So the discomfort is, in effect, control for the missing data that is being observed. So that comfort level, that data, could actually be used as sort of a control feature that would help us be able to predict the missing data within the data set. Okay, so again, these are kind of complicated ways to deal with trying to understand how missing data happens, but being able to predict the predictable part of missing data is where this technique is getting to. And it's kind of an idea that we're focused on again with the MAR type of data that we might be able to use there a little bit. So remedying though missing data and getting beyond this, if you choose to drop data or count for data in a couple different ways, we have traditionally pairwise and listwise replacement of data or elimination of data. So when we use a pairwise approach, sometimes we call it the all available information approach. So we use all the available information that's there. However, what we recognize is that not all the variables will have the same number of responses. So if we have a sample set of 100, and if 95 people responded to one variable and 92 people responded to a different variable, we've got some missing data in there, but we're still going to use our all the data that we have available. So if we did a correlation between those two variables, we can only use the responses in which we have both variables present. So what that means is for each calculation, for each estimation, we may have a different sample size. So the sample sizes will change for each calculation that we do based on how many people respond to each variable. It's probably the most effective way to use your data, generally speaking. I mean, you get the most power generally, but there's inconsistency in sample size across the different estimations that we do when we do a pairwise approach. A listwise approach is when we do a case-by-case approach, and we only use cases in which all the data is available. So in this case, what we're going to do is anybody who doesn't complete all the survey or the entire survey, their case will be dropped. So each case has 100% information, but we don't use 100% of all the cases. So that's a different way to think about deleting or using missing data. The third way then is to replace our data, which is called imputation, and we can replace our data by using some type of specific method. So a very, very common way to do this is to take the mean of the variable, and wherever there's a missing data point in that variable, insert the mean. So if we have a variable and say 95 out of 100 people responded to that variable, then what we would do is we would take the average of those 95 respondents, and we would put the average and we would insert that in to the 5 respondents who did not give us an answer for it. So mean replacement then replaces, and that gives us 100%, it replaces all the missing data with the mean replacement. The hot-cold deck approach is a little bit more challenging. What we do is we look at, we take each case and we look at the missing data, and we look at other respondents who are very similar to the respondent who has the missing data, and whoever is the closest respondent, like in other variables, we replace the missing data with those variables, with those respondents that are closest or more similar to the respondent who did not, who provided the missing data. Okay, so that's the hot and cold deck approach. And then finally, we can create regression models that would predict what a person would input in that missing data spot based on the other data that is returned. So in other words, we can create a model to predict, and so the dependent variable would actually be the missing data that's there, the missing variable, and so we could create a model to predict what somebody would put in a missing data variable, and then we can input that. We could estimate what that would be and input that. So that's called imputation, when we choose to replace or input a data point for missing data. And this is certainly these three methods. I use mean replacement a lot, actually, because it's easy and simple to do, and it gives a value, and it doesn't really hurt your data set. It doesn't predictably change the outcome of your data. Let me rephrase that. Because it's using the mean, so it's not overstating or understating that particular variable for any of the respondents that are missing. So those are definitely ways we can deal with missing data and how we want to change that. Some general rules of thumb: if there's under 10% missing data, then you can use any of the imputation methods. So the 3 imputation methods that we just talked about, the hot-cold deck, the regression formula or modeling approach, or the mean replacement can be used. And again, I use mean replacement quite a bit to be able to do this. So we can do that. You can also though use pairwise or listwise deletion as well. I tend to very rarely use listwise deletion. I don't feel very comfortable deleting respondents who, because somebody might have responded to the survey, and even though they're missing data, the data they do provide, I assume, is valid. So I hate to throw out data because it really reduces the power of your overall your overall analysis. 10 to 20% missing data is again an imputation situation where you can use case substitutions and regression models to help predict that. Over 20%, if you need to use an imputation method again, the regression model and hot-cold deck approaches are more robust. Those are the most robust methods that can be used. So the more missing data that you have, if you have to keep the variable, then that's what you'd probably want to do. Okay, so this has been a kind of a wrap-up of missing data, how to deal with missing data, how to identify missing data, and what the types of remedies that you might want to use as you deal with addressing your data that way.